What's up, good people? This is section R4, Review Chapter, fourth section on factoring. So here we go. But before we actually start, I just want to remind you that when questions come up, because they always come up for whatever reason, no video is perfect. No video is going to perfectly suit every single need that everyone has. When the questions come up, just write them there and bring them to class. If you don't want to Google it, if you don't want to text a friend or Snapchat or whatever, whatever you guys do, it's all good. If you just want to bring it to class, write it there. And secondly, I want to make sure that everyone's listening, because I know all you awesome people are. I just want to verify it, and so I'm going to be dropping some personal information, and when I do, you can just write it down in the audio check. So, let's get started. Factoring. So one thing to always do first step, factor out the greatest common factor, the GCF, or even factor out, do some grouping. Let me just show you what that means. The greatest common factor. Well, no single number goes into 23 and 12, but I do see an x squared and a y that are factors of both. So what I can do is I can say x squared y on the outside, put a set of parentheses, and then I ask myself, x squared y times what gives me 23x cubed y? That's going to have to be 23x. And then x squared y times what gives me 12x squared y? 12. And since you can't factor 23x plus 12, then you are finished. And that's the answer. Now sometimes factoring out the greatest common factor, you might see that it's more than just a single monomial. Maybe a binomial is a factor of both terms. Like, check this out. You see p plus q, and p plus q is in both. So it's like the format a b plus a c. If you factored the a out, it would be a times b plus c. Because if you were to distribute, you would go back to this here. So we're doing the reverse of distributing. We're factoring. P plus q goes on the outside. That's the a term. And then we have x plus 2 plus x plus y. If I can color code it all, you'd see it like this. It's the yellow part that gets factored out. You see yellow twice. P plus q is in both terms, so you factor it out. Sometimes that yellow part, that polynomial, is not immediately present. So what you can do is you can just take a look at the first two terms and say, well, what's the greatest common factor there? I think you can factor out 4x squared from both terms. 4x squared times what gives you 4x cubed? That's just going to be x. 4x squared times what gives you 20x squared? That's going to be 5. Now, what if you could factor out x plus 5 from the other two terms? Well, you actually can. You have to just ask yourself, x plus 5 times what gives you negative 3x minus 15, and that's going to be negative 3. And now x plus 5 becomes the term, the factor that's in both terms. So I'll write x plus 5 and then x plus 5, let's see, and then we've got 4x squared plus or minus 3. Again, the trickiest part is always the first part. And what do you do when you're grouping? You have to figure out what is the greatest common factor between the first two terms. And you see it's x plus 5. Once you discover the x plus 5, then you carry it all the way down. Alright, first technique. Products of sums and differences. A plus b times a minus b. If you want me to show you why this is true, I can show you in class, but I'm not going to, it's going to be a long enough video as it is, so I'm just going to say that it's true. A plus b times a minus b is a squared minus b squared. So what you can do with that fact is you can say, this looks like a perfect square, and this looks like a perfect square. It's a difference of perfect squares. What times itself is 25y to the fourth? That would have to be 5y squared. And what times itself is 16x squared? That would have to be 4x. So what I really have here is a squared minus b squared, which is the same thing. It's equal to a plus b times a minus b. And so therefore, I know, back substituting, I know that this is 5y squared plus 4x times 5y squared minus 4x. And that's how you factor that. Here, I don't exactly have a difference of perfect squares. I mean, I do know that x times itself is x squared, but 3? What number times itself is 3? No easy number, like no integer for sure. But I can say that it's just the square root of 3 times itself is 3. Because it's a trick you can always do. Okay, so if that's true, then what I really have is a squared minus b squared. And that's equal to, I know, a plus b times a minus b. Back substituting, you get x plus the square root of 3 times x minus the square root of 3. And you're done. Alright, let me show you how to use a factor x. There's lots of ways that teachers use to factor these trinomials, but I think the best way that I've seen is to use a factor x. And what this looks like is every trinomial has an a term, a b term, and a c term. Here c is equal to 5, b is equal to 6, and a is equal to 1, because there's always an imaginary 1 in front of every term. When a is equal to 1 and you've got a quadratic trinomial, you need a quadratic trinomial, meaning you've got a squared here and there's 3 terms, x squared, an x term, and a constant term. When you have those perfect conditions, a is 1, the highest exponent is 2, and you've got 3 terms, then you take the b term and you put it here. So, sorry, not the term, the coefficient. The number in front is 6. The value of b, you put it there. Put b here. And then you put c in the bottom. In this case, it's 5. And then you have to ask yourself, what are the factor pairs of 5? In this case, it's pretty easy because 5 is a prime number. It's just 1 and 5. And look, 1 and 5 add up to 6. 1 and 5 are a pair of numbers that multiply up to 5 and add up to 6, and that's what we're looking for. X plus 1, x plus 5. And you're done. If you were to FOIL these, you would get back to the original. So really the whole point of factoring is undoing the multiplication, undo the FOIL. Let's do that again here. So we've got a factor x. A is equal to 1, b is equal to 5, and c is equal to negative 14. B goes in the top, C goes in the bottom. You have to ask yourself, what pairs of numbers multiply up to negative 14? I can say it's 1 and negative 14, 2 and negative 7, 3, 4, 5, 6, 7, 7 and negative 2, 7 and negative 2, and then 14, and negative 1. Now, which of these will add up to positive 5? Be very careful because this one adds up to negative 5, but this is the one that you really want. 7 plus negative 2 is positive 5. Two numbers that multiply up to negative 14 and add up to 5. So here we go. X plus 7 and then x minus 2. That's how we do it. I'm going to do both of these at the same time. I'm going to show you factor x, but I'm going to do a U-substitution first. So here, we don't have a quadratic trinomial, we've got a quartic trinomial. Look at this, 4, yikes, and a 2, that's not what we're looking for. We need lower exponents than that. These exponents are too high. So what you can do is you can do a U-substitution, and that just means I'm going to let u equal w squared. This works because it's a 4 and a 2 in a special case. But if you rewrite the whole trinomial, it becomes u squared minus 7u plus 10. And now we've got a quadratic trinomial. Now the exponents are exactly the way we want them. I'm going to do a factor x on this trinomial instead. I want to know what two numbers add up to negative 7 and multiply up to positive 10. Well, what are the factor pairs of 10? We've got 1 and 10, 2 and 5, and that's it. Neither of these add up to negative 7, because 2 plus 5 is positive 7. But what if I just do this? What if I just make them both negative? Negative 2 times negative 5 is still positive 10, so that's what we need. Negative 2 and negative 5 multiply up to positive 10 and add up to negative 7, so I've factored it. U minus 2, U minus 5. But what I need to do now is reverse, we need to back substitute the U substitution. What is U? It's W squared. W squared minus 2, and then W squared minus 5. But I think we can go even further than that, because look, check this out. Oh, from the previous page, we learned how to factor a difference of squares, and I know no easy number times itself is 2, but I can say that here a is equal to w and b is equal to square root of 2. So what I really have is a squared minus b squared, which is the same thing as a plus b times a minus b. So back substituting one more time, I get w plus square root of 2, w minus square root of 2. And it's the exact same thing that's going to happen over here. W plus square root of 5, w minus square root of 5. Wow, what an awesome problem. We got to use like 3 tricks all in a row. U-substitution, U-substitution, a factor x, and 2 different difference of squares. That is how you perfectly factor that all the way down. Okay, next technique I want to show you, bottoms up. If your Algebra 1 teacher hasn't showed you, or Algebra 2 teacher hasn't showed you bottoms up, then I highly recommend you Googling it. Just be careful about how you Google it, because if you just Google bottoms up, then you might get a whole lot of search results that your mama might not like you seeing. So do like algebra bottoms up or bottoms up method of factoring, something like that. You'll be fine. So by the way, we've got the exponents the way we need them, 2, 1, and then a constant term. And we have a b term and a c term. But look, this is different. A is 3, so how do we handle that? Well, we're going to do a factor x, yes. And bottoms up, we use the factor x, the b is up there, and then for down here we multiply a times c. So in this case, a times c is 6. 5 up there, 6 down here. And then we proceed We have to ask ourselves, what are the factor pairs of 6? There are 1 and 6, and 2 and 3, and these add up to 5, so I've got 2 and 3 here. Great. So 2 and 3 are a pair of numbers that multiply up to 6 and add up to 5. Therefore, we can say this is x plus 2 and x plus 3. Now, the interesting thing here is that you have to go a few steps further and use this a value again at the bottom. We're going to make fractions. 2 over 3 and 3 over the a value. You put the a value right here, 3 and 3. And then you're always going to be able to cancel out at least one of the fractions in some way. This becomes x plus 1. Now the fraction you can't cancel out, here's where the bottoms up name comes from. You take the denominator and you actually move it up here. 3x plus 2. I could show you why this works, but it's an incredible technique and it shortens everything. It takes a lot of guesswork out. And I love it. So if you don't know it, get used to it. 3x plus 2, x plus 1. If you were to FOIL those, you'd get right back up to the original. But this is the process that is the reverse of FOILing. Alright, check this out. Wait a minute, I see a greatest common factor. The greatest common factor between all three of these terms is going to be 3. So let's factor that out first. 3. See, 3 times what is 6x squared? That's 2x squared. 3 times what is 9x? That's going to be 3x. And 3 times what is 60? That's going to be 20. Okay, now we can do, since we have a quadratic trinomial, I'm going to use bottoms up because a is equal to 2, b is equal to negative 3, c is equal to negative 20. The b value goes on the top, and a times c is going to be 2 times negative 20, which is negative 40. You have to ask yourself, what are the factor pairs of negative 40? 1 and negative 40, 2 and negative 20, 4 and negative 10, 5 and negative 8, and you could go on for a long time actually, but I see the one that I need. It's 5 and negative 8. 5 times negative 8 is negative 40, and 5 plus negative 8 is negative 3. First of all, I'm going to bring this 3 down. It's going to stay with me. Very important. And so we can say this is x plus 5, and then x minus 8. I'm going to take the a value, which is 2, and I'm going to turn those into fractions. Moving forward, we get 3 times x. Let's see, this does not cancel, so I'm going to bring the bottom up, 2x plus 5, and then this does cancel to x minus 4. And if you were to FOIL these, you would get right back to the original. I think we've got a greatest common factor of 3 and a U-substitution of x squared. So when you do those two things, you see you've got 3. Actually, I'm going to do a negative 3, and I'll show you why. Negative 3, and that's going to be 4u squared minus 20u plus 25. Now, why did I choose negative 3? That's because we really enjoy having a values being positive. So if I made that negative 3, then this becomes a positive 4. The a value is 4, the b value is negative 20, and the c value is 25. Big old factor x, a times c is 100. And the b value is negative 20. So we need factor pairs that multiply up to 100. That's 1 and 100, 2 and 50, 3, not 3. 4 and 25, 5 and 20, 10 and 10. Well, none of these add up to negative 20. At the best, this one adds up to positive 20, so I can actually make them both negative, and it's still negative 10 times negative 10 is still positive 100, but they add up to negative 20. So, great. We've got negative 3, negative 3 times u minus 10 times u minus 10. And if I back substitute, then we get negative 3 x squared minus 10 x squared minus 10. This is just a difference of squares, and in fact, and it's going to work out the same way. A could be x, and b could be the square root of 10. So I know this is a plus b times a minus b, which is negative 3 times x plus the square root of 10 times x minus the square root of 10. And we do that twice, because it's the same factor. X plus the square root of 10, and then x minus the square root of 10. This technically could be one answer, but I'm going to go one step further and say we've got two of them. X plus square roots of 10 squared, x minus square root of 10 squared. And that is a fantastic problem. It practices so much. It is complex, but if you understand all the different steps, then I'd say you're in good shape. If you don't, ask a question when we get back to class. Okay, so the next pattern I'm going to show you is this. If you were to actually FOIL a plus b times a plus b, you'd get, as a first term, you'd get a squared, and as a last term, you'd get b squared. But as the outside term, you'd get ab, and then as the inside terms, you'd get ab also. So you get two ab's. Adding them together, you get 2ab, which is exactly what the pattern is. Throw in a negative sign, and basically it results in this negative right here. So here's the formula, and we're going to hopefully memorize it pretty soon, because we'll be using it so much and writing it down so much, and if that doesn't work, then make flashcards. But here we go. I think we have an a squared minus 2ab plus b squared situation. That's because I can see this is a perfect square here. What times itself is 9y squared? It's 3y. And what times itself is 25? That's just 5. So the real question is this going to be 2ab? Let's find out. 2ab, let's do some side work. 2ab would be 2 times 3y times 5. And yeah, 2 times 3 times 5 is 30y. And that's exactly what we have here. We've got 30y. So it looks like we do have an a squared minus 2ab plus b squared situation. And the formula that we have memorized says that this is the same thing as a minus b squared, which, back substituting, we get 3y minus 5 squared. That's our answer. Let's do the same thing here. I notice that I've got a perfect square trinomial, and this is x squared and y squared. So what times itself is 16x squared? That's going to be 4x. What times itself is 81y squared? That would be 9y. And the question is this 2ab? Let's find out on the side. So what would 2ab calculate out to be? 2 times a, which is 4x, times b, which is 9y. 2 times 4 times 9, well, 2 times 4 is 8, times 9 is 72, xy. Yeah, we've got a 2ab in the middle. That middle term is definitely 2ab. So what the quadratic looks like is a squared plus 2ab plus b squared, which, as the formula dictates, is the same thing as a plus b squared. So, back substituting, we get 4x plus 9y squared. That's our answer. Next formula, cubes. Sum of cubes, difference of cubes. These we're going to memorize also, because we're going to write them down and use them so much. I see a difference of cubes. What number times itself 3 times is 8? That's 2. What number times itself 3 times is x? That x cubed, that's going to be x. So what I have is a cubed minus b cubed. And because I have it memorized, the formula is saying that this is the same thing as a minus b times a squared plus ab plus b squared. So back substituting is going to be x minus 2 times x squared plus 2x plus 4. And you're done. I want you to do the same exact thing with 64 minus t cubed. Do the same formula, same procedure like this. Pause the video, and when you're finished, move on to number 17. This looks like a set of perfect cubes. So we have to ask yourself, what times itself is 8m cubed? That's 2m. What times itself is 125? T cubed, that's 5t. 5 times 5 times 5 is 125. So what I really have is a sum of cubes, and the formula says that that's the same thing as a plus b times a squared minus ab plus b squared. Back substituting, we get 2m plus 5t. 2m squared is 4m squared. 2m times 5t would be 10mt. It's so empty. And then b squared is going to be 25t squared. And you're done. So, that's it. That's everything. And what I'd like you to do is start assignment RD. I want you to get out your composition book. I want you to write the problem list out at the top of your composition book, and then just start the first problem. And that should give you plenty to talk about when we get back to class. Take care, and I'll see you then. Oh, one more thing, the audio check. I want to let you know my favorite movie is Lord of the Rings. Yes. Tell me your favorite movie in class.